Whether you're sipping your morning coffee or catching up later, we've got your industry insights. I'm Steve.
And I'm Claire. Welcome to Auto Intelligence, produced by Agentic AI.
New episodes drop every Tuesday, Thursday, and Saturday. And today, we're diving into something that's fundamentally reshaping how we think about vehicle design, deployment, and business models.
That's right, Steve. We're talking about cities as test labs, how urban planning innovations from Singapore to Stockholm are creating entirely new requirements for automotive manufacturers, suppliers, and technology companies.
Claire, I was just reading about Singapore's latest smart mobility initiatives, and it got me thinking, are current automotive communication protocols robust enough for the level of integration these cities are demanding?
It's a massive challenge, Steve. Cities globally are rewriting the rulebook for how vehicles operate within them, what data they need to share, and how they integrate with urban infrastructure. That's exactly what we're exploring today.
For our listeners in automotive, whether you're in R&D, strategy, manufacturing, or supply chain, this isn't just about urban planning. This is about understanding the new operating environment that's going to define vehicle requirements for the next decade.
Let's start with Singapore, because if there's a city that embodies systematic vehicle infrastructure integration, it's this island nation. Steve, Singapore's approach to smart mobility isn't just about managing traffic. It's creating a completely new paradigm for how vehicles need to communicate and operate.
Absolutely. And what's fascinating is the scope of their integration. According to Singapore's Land Transport Authority's 2024 annual report, their intelligent transport system now covers over 90% of the island's major roads with real-time monitoring capabilities.
Talk about that integration challenge, Steve. What does this level of urban intelligence mean for vehicle design?
Well, first, it means vehicles can't be designed in isolation anymore. Singapore's Smart Mobility 2030 plan explicitly calls for vehicle-to-infrastructure communication as a core requirement for operating in their urban environment.
That requires vehicles with sophisticated V2X capabilities, not just basic communication, but the ability to receive, process, and act on complex urban data streams.
And that's where it gets interesting for OEMs. Singapore's approach is fundamentally changing the requirements for vehicles operating in dense urban environments. According to research from the Singapore-MIT Alliance for Research and Technology, future urban vehicles will need to function as integrated nodes in citywide transportation networks.
It means a fundamental shift in how we think about vehicle computing power and data processing. Singapore's electric vehicle infrastructure is expanding rapidly. They've set a target of 60,000 charging points by 2030.
But more importantly, each charging station is designed as a data collection and communication point. Vehicles need to be designed not just to charge, but to contribute to and benefit from this urban intelligence network.
Let's get specific about the technology requirements. Singapore's autonomous vehicle trials have been running since 2015, and according to their Committee on Autonomous Road Transport for Singapore report, they've identified specific technical standards that vehicles must meet to operate in their environment.
The key insight is about sensor fusion at the urban scale. Singapore's vehicles aren't just relying on onboard sensors, they're integrating real-time data from traffic cameras, road sensors, and pedestrian movement patterns.
For automotive suppliers, this means developing sensor suites that can seamlessly integrate with urban infrastructure, not just operate independently.
And there's a cybersecurity dimension here that's crucial for our industry. Singapore's cybersecurity agency has published specific guidelines for connected vehicle security in smart city environments. Claire, how does this impact automotive cybersecurity strategies?
It's forcing a complete rethink. Traditional automotive cybersecurity focused on protecting the vehicle as an isolated system. Now, vehicles need to securely participate in citywide networks while protecting both their own systems and the urban infrastructure they're connected to. It's exponentially more complex.
So Singapore shows us the power of centralized urban intelligence. But Stockholm takes a different approach with its mobility as a service initiatives. Claire, from an OEM perspective, does this integration of multiple mobility services present more of a challenge or an opportunity?
That's the key question, Steve. Stockholm's approach, documented in their 2023 mobility strategy, focuses on integrating multiple transport modes into seamless user experiences.
What's particularly interesting is that 43% of Stockholm residents now regularly use some form of shared mobility service.
And that's not just a transportation statistic, that's a fundamental shift in the automotive business model.
Exactly. Traditional OEMs are seeing this and asking, Do we become suppliers to MaaS platforms, or do we launch our own? Volvo, being Swedish, has been particularly active here.
They've integrated their M-Mobility service with Stockholm's broader mobility ecosystem, essentially turning their vehicles into nodes in the city's mobility network.
Let's talk about the technical integration challenges. According to research from the KTH Royal Institute of Technology, successful MaaS implementation requires real-time availability data, dynamic pricing, and seamless handoffs between different transport modes.
What does this mean for vehicle connectivity requirements?
It means vehicles need to be constantly communicating their status, location, and availability. But more than that, they need to integrate with payment systems, user authentication, and route optimization algorithms.
We're talking about vehicles that are essentially mobile service platforms, not just transportation devices.
And the data implications are significant. Stockholm's Transport Authority reports in their 2024 annual statistics that their integrated public transport system handles over 1 billion passenger journeys annually.
For automotive companies, this represents valuable user behavior data if they can access it appropriately.
That's the key challenge, Claire. Who owns the customer relationship in a MaaS world? Is it the platform, the vehicle manufacturer, or the city?
Stockholm's approach has been to maintain public oversight while allowing private innovation, but that creates complex data sharing agreements that automotive companies need to navigate.
Speaking of navigation, let's talk about the infrastructure requirements. Stockholm's success with integrated mobility required significant investment in digital infrastructure. How does this impact automotive R&D priorities?
It's forcing automotive companies to think like technology companies. Traditional automotive R&D focused on mechanical engineering, safety, and performance. Now, companies need expertise in cloud computing, data analytics, and platform integration. It's a completely different skill set.
Let's shift to Copenhagen because their cycling infrastructure represents something really interesting for automotive design. Claire, when a city successfully achieves 41% of commuter trips by bicycle, what does that mean for vehicle manufacturers?
It's not just about fewer cars, Steve. It's about completely rethinking urban vehicle footprints. Copenhagen's cycling superhighways, documented in their Bicycle Account 2022, show that major cycling routes can handle significant commuter volumes.
For automotive designers, this creates opportunities for smaller, more specialized urban vehicles.
And we're seeing that innovation already. Copenhagen's integration of cargo bikes for last-mile delivery has sparked interest from automotive suppliers. Companies like Continental are developing electric assist systems specifically for urban cargo applications.
That's a perfect example of how urban planning drives automotive innovation. Copenhagen's bike infrastructure isn't just about personal transportation. It's created an entire ecosystem of electric-assisted cargo vehicles that didn't exist 5 years ago.
Let's talk about the technology integration. Copenhagen's smart traffic signals, part of their ITS Copenhagen initiative, prioritize cyclists, but also communicate with vehicles.
How does this multimodal signal system impact automotive sensor requirements?
Vehicles operating in Copenhagen need to understand and respond to traffic signals that are optimized for multiple transportation modes simultaneously. This requires more sophisticated computer vision and AI systems that can interpret complex urban environments where bikes, pedestrians, and vehicles all have different priority levels at different times.
And there's a fascinating data element here. According to Copenhagen's Smart City Strategy, the city's cycling network generates substantial data on movement patterns, weather impacts, and infrastructure utilization that helps optimize the entire transportation system.
That level of granular data about urban movement patterns is incredibly valuable for automotive planning. Understanding when, where, and why people choose different transportation modes helps automotive companies design vehicles and services that complement rather than compete with urban infrastructure.
Copenhagen's approach also highlights the importance of weather resilience. Their cycling infrastructure operates year-round, even in harsh Nordic winters. For automotive manufacturers developing urban mobility solutions, this demonstrates the need for all-weather reliability in compact, efficient vehicles.
Now let's talk about Dubai, because their autonomous vehicle strategy represents perhaps the most aggressive timeline we're seeing globally. Steve, Dubai's autonomous transportation strategy aims for 25% autonomous trips by 2030. What specific challenges does this create for automotive manufacturers?
It's not just about building autonomous vehicles, Claire. It's about building vehicles that can operate in Dubai's specific urban environment. According to the Roads and Transport Authority's strategic plan, they're creating dedicated infrastructure, including connected traffic signals and autonomous vehicle corridors with embedded sensors.
And that infrastructure specificity is crucial. Dubai's approach requires vehicles with sensor suites calibrated for desert conditions, extreme heat, and the unique traffic patterns of a rapidly growing city.
It's not enough to develop a generic autonomous vehicle. You need one optimized for Dubai's specific operating environment.
Let's talk about the regulatory innovation happening there. Dubai's Centre of Excellence for Autonomous Transportation has streamlined approval processes for autonomous vehicle testing. For automotive companies, this represents a significant opportunity for accelerated development and deployment.
But it also creates pressure. Dubai's timeline means automotive companies can't wait for perfect technology. They need to deploy iteratively and improve through real-world operation. That's a fundamental shift from traditional automotive development cycles.
The economic implications are substantial too. Dubai's RTA projects that autonomous vehicles could significantly reduce traffic accidents and transportation costs, though they're careful to note these are projections based on current technology trends rather than guaranteed outcomes.
And let's not forget the infrastructure investment. Dubai has committed substantial resources to smart city infrastructure to support autonomous vehicles. This level of public investment creates market opportunities, but also raises the stakes for automotive companies to deliver on their autonomous promises.
You're listening to Auto Intelligence, brought to you by Autoagentic,
the platform transforming automotive retail with intelligent, human-centered AI. But what makes Autoagentic truly unique is their work directly with OEMs and their approach to customizing workflows for the next wave of agentic AI.
That's right, Steve. While many AI companies focus on one piece of the puzzle, Autoagentic bridges the entire automotive value chain, from manufacturer to dealer to customer. They're working with major OEMs to develop customized AI workflows that integrate seamlessly across manufacturing, distribution, and retail operations.
And their next-generation agentic AI capabilities are designed specifically for the automotive industry's complexity. We're talking about AI agents that understand everything from supply chain logistics to customer financing preferences, all working together in coordinated workflows.
What's particularly impressive is their consultative approach. Rather than offering one-size-fits-all solutions, they work with each OEM to understand their specific challenges and customize AI implementations that align with existing processes while driving innovation.
Learn more at autoagentic.ai. Now back to our exploration of how cities are reshaping automotive requirements.
Steve, let's dive into what might be the most transformative technology we haven't fully discussed yet: digital twins. Cities are creating virtual replicas of their entire transportation systems, and this has massive implications for automotive development.
Absolutely, Claire. The University of Michigan's M-City has developed digital twin capabilities that allow extensive simulation of autonomous vehicle scenarios before physical testing. For automotive companies, this represents a fundamental shift in how we approach vehicle development and validation.
And it's not just about testing individual vehicles. These urban digital twins can simulate the interaction between thousands of vehicles, pedestrians, cyclists, and urban infrastructure simultaneously.
Research from MIT's Sensible City Lab indicates that digital twins allow cities to test the unintended consequences of transportation innovations before they impact real urban environments.
That's crucial for automotive manufacturers because it means we can understand how our vehicles will perform not just in isolation, but as part of complex urban ecosystems.
Traditional automotive testing focused on individual vehicle performance, acceleration, braking, handling. Now we need to understand how vehicles behave in dynamic, multimodal urban environments.
Let's talk about the data requirements. Creating accurate digital twins requires massive amounts of real-world data. Cities like Singapore and Barcelona are investing heavily in sensor networks and data collection infrastructure to support these virtual models.
And the computational requirements are staggering. Running realistic simulations of urban transportation systems requires cloud computing resources that most automotive companies don't currently have in-house.
This is driving partnerships between automotive manufacturers and cloud computing providers like AWS, Microsoft, and Google.
There's also an interesting standardization challenge emerging. Different cities are developing digital twins using different platforms and data formats. For automotive companies operating globally, this could mean developing vehicles that need to interface with dozens of different digital twin systems.
That's where industry collaboration becomes crucial. Organizations like the Digital Twin Consortium are working on standardized protocols for automotive applications, but we're still in the early stages of this standardization process.
This brings us to our AI segment, Claire. And today we're focusing on a critical interface. How does AI-driven urban traffic management communicate with AI-powered vehicles? This isn't just a technical challenge, it's about creating symbiotic intelligent systems.
That's the key word, Steve, symbiosis. Traditional automotive AI focused on making individual vehicles smarter. But cities like Los Angeles, which has deployed adaptive traffic control systems across thousands of intersections, require vehicles to integrate with urban AI systems.
And the complexity is enormous. These systems need to process millions of vehicle movements and adjust signal timing in real time. For autonomous vehicles, this means their AI systems need to predict not just traffic patterns, but how the city's AI will respond to those patterns.
It's like having two AI systems trying to optimize the same environment, which could lead to unpredictable behaviors. That's why companies like Waymo and Cruise are working directly with cities to ensure their vehicle AI systems can communicate effectively with urban traffic management AI.
Let's talk about the data sharing protocols. Cities want to optimize overall traffic flow, while individual vehicles want to optimize their own routes. These objectives don't always align. How are automotive companies addressing this potential conflict?
Some companies are developing what they call cooperative AI. Systems that can balance individual vehicle optimization with overall urban efficiency. But this requires vehicles to share more data with city systems, which raises privacy and competitive concerns.
And there's a standardization challenge here too. Different cities are using different AI platforms and communication protocols. The automotive industry needs to develop solutions that can work across multiple urban AI systems.
The edge computing dimension is fascinating too. Rather than sending all data to the cloud, cities and vehicles are processing AI decisions locally. This reduces latency, but requires more sophisticated onboard computing power in vehicles.
Looking ahead, we're seeing the emergence of what researchers call distributed urban intelligence, AI systems that span vehicles, infrastructure, and cloud computing. For automotive companies, this means thinking beyond individual vehicle intelligence to participate in citywide AI ecosystems.
Steve, as we look across all these urban innovations, from Singapore's integrated systems to Dubai's autonomous corridors, there are some clear technology trends that automotive companies need to understand and prepare for.
Absolutely. First is the shift from vehicle-centric to system-centric design. Cities are creating integrated mobility ecosystems where vehicles are just one component. This requires automotive companies to develop systems thinking capabilities, not just vehicle engineering expertise.
Second is the data imperative. Every city we've discussed is generating substantial amounts of transportation data. Automotive companies that can access, analyze, and act on this urban data will have significant competitive advantages in vehicle design, service development, and market positioning.
Third is the infrastructure dependency. Unlike traditional automotive markets where vehicles operated independently, these urban innovations require vehicles designed for specific infrastructure capabilities. This could lead to regional specialization in vehicle design and manufacturing.
And fourth is the speed of change. Traditional automotive development cycles of 5 to 7 years are too slow for rapidly evolving urban environments. Cities like Dubai are implementing changes in months, not years. This requires automotive companies to develop more agile development and deployment capabilities.
Let's talk about the supply chain implications. These urban mobility systems require components and capabilities that traditional automotive suppliers may not have: cloud computing integration, real-time data processing, urban sensor fusion. How is this reshaping automotive supply chains?
We're seeing automotive companies partner with technology companies in unprecedented ways. Traditional Tier 1 suppliers like Bosch and Continental are acquiring software companies and developing cloud computing capabilities. Meanwhile, technology companies like NVIDIA and Qualcomm are becoming critical automotive suppliers.
And there's a talent dimension here too. Automotive companies need urban planners, data scientists, and cloud computing experts, skills that weren't traditionally part of automotive engineering teams. This is driving both internal hiring and external partnerships.
Steve, let's get practical for our listeners. If you're working in automotive strategy, R&D, or business development, what are the immediate implications of these urban mobility trends?
First, market segmentation is becoming more complex. Instead of just thinking about consumer preferences, automotive companies need to understand urban infrastructure capabilities and regulatory environments.
A vehicle designed for Singapore's smart city infrastructure might not be optimal for a city with less advanced systems.
Second is the business model evolution. Traditional automotive revenue came from vehicle sales and aftermarket services. These urban mobility systems create opportunities for data services, platform integration fees, and mobility-as-a-service revenue streams.
Third is the partnership imperative. No single automotive company can develop all the capabilities needed for these integrated urban systems. Success requires partnerships with cities, technology companies, and other mobility service providers.
Let's talk about investment priorities. Where should automotive companies be focusing their R&D spending to prepare for these urban mobility futures?
Vehicle connectivity and data processing capabilities are crucial. Every city we've discussed requires vehicles with sophisticated communication and computing capabilities. Companies that underinvest in these areas will be locked out of the most advanced urban markets.
Software development capabilities are equally important. These urban systems require vehicles that can be updated and reconfigured remotely. Automotive companies need to develop software development and deployment capabilities similar to technology companies.
And don't underestimate the importance of regulatory and policy expertise. These urban mobility systems involve complex interactions between private companies and public infrastructure. Automotive companies need teams that can navigate these regulatory environments and influence policy development.
There's also a geographic strategy dimension. Cities are developing these capabilities at different speeds. Automotive companies need to decide whether to focus on the most advanced markets first or develop solutions that can scale across different levels of urban infrastructure sophistication.
Steve, while these urban mobility innovations create enormous opportunities, they also present significant challenges and risks for automotive companies. Let's be realistic about what companies need to prepare for.
The biggest risk is probably technology fragmentation. If different cities develop incompatible systems, automotive companies could face the scenario of needing different vehicle configurations for different urban markets. This would eliminate economies of scale and dramatically increase development costs.
Cybersecurity is another major concern. These integrated urban systems create much larger attack surfaces than traditional vehicles. A cybersecurity breach could affect not just individual vehicles, but entire urban transportation systems. The liability and reputational risks are enormous.
Data privacy and ownership issues are still largely unresolved. Cities want access to vehicle data for urban planning, but automotive companies view this data as a competitive asset. We need clear frameworks for data sharing that protect both urban planning needs and commercial interests.
And let's not forget the digital divide implications. These advanced urban mobility systems could create two-tier transportation markets, high-tech solutions for wealthy cities, and basic transportation for everyone else. Automotive companies need to consider the social and political implications of this potential divide.
There's also the question of technological obsolescence. Cities are investing billions in current generation smart infrastructure, but technology is evolving rapidly. Automotive companies need to balance compatibility with existing systems against the need to prepare for next-generation technologies.
Regulatory uncertainty is another significant challenge. Many of these urban mobility innovations are operating in regulatory grey areas. Changes in regulations could dramatically impact the viability of current business models and technology investments.
As we wrap up, Claire, let's look ahead. What should automotive industry professionals be watching for in the next 12 to 18 months?
First, watch for standardization initiatives. Organizations like the Society of Automotive Engineers and the International Organization for Standardization are working on standards for vehicle infrastructure communication. These standards will determine which technologies become dominant and which become obsolete.
Second, monitor urban pilot programs. Cities around the world are launching mobility innovation pilots in 2025. The results of these pilots will influence urban mobility strategies globally and create market opportunities for automotive companies.
Third, pay attention to regulatory developments. The The European Union is developing comprehensive regulations for connected and autonomous vehicles in urban environments. These regulations will likely influence global standards and create competitive advantages for companies that comply early.
And watch for technology partnerships. The most successful automotive companies in this new environment will be those that build the strongest ecosystems of technology partners, urban relationships, and platform integrations.
For our listeners, the key message is that urban planning isn't a spectator sport anymore for automotive companies. Cities are actively shaping vehicle requirements, business models, and competitive dynamics. Understanding and engaging with these urban innovations is essential for automotive success.
And this is just the beginning. As cities become more sophisticated in their mobility planning and technology deployment, the integration between urban systems and vehicles will only deepen. Automotive companies that start building these capabilities now will have significant advantages in the markets of tomorrow.
So whether you're in Detroit, Stuttgart, Tokyo, or anywhere else in the automotive world, remember that the future of your industry is being written in the planning offices and test corridors of Singapore, Stockholm, Copenhagen, and Dubai.
These cities aren't just customers, they're co-developers of the automotive future. And understanding their innovations, challenges, and requirements is essential for anyone working in automotive strategy, technology, or business development.
Thanks for joining us on Auto Intelligence. This episode was produced by the team at Autoagentic, the platform transforming automotive retail with intelligent, human-centered AI.
Autoagentic delivers over 90 modular AI agents, helping dealerships thrive in a fast-evolving market. But what truly sets them apart is their direct partnerships with OEMs and their pioneering work in next-generation agentic AI workflows.
They're not just building AI tools, they're creating customized AI ecosystems that bridge the entire automotive value chain, from manufacturing to retail. Their consultative approach means each implementation is tailored to specific OEM requirements and dealer network needs.
Because true agentic AI isn't just about automation, it's about strategic thinking, collaborative planning, and operational integration across the entire automotive ecosystem. That's why they're known as the most human AI company in automotive.
Learn more at autoagentic.ai. We'll be back Thursday with more insights from the intersection of automotive and technology.
Until then, keep innovating.